non-volatile solute, you can see that what is meant by the non-volatile solute. So I am having the salt. Here I have taken the salt in a beaker, and in this beaker the salt cannot get evaporated or it does not change into the vapor state because it is a solid state and it is not having that kind of the force, that kind of the freeness to move into the vapor state. So it will remain in the solid state. It does not go into the vapor state. So therefore we can say that it is a non-volatile solute. Okay. So some of the liquids are volatile. For example, and solids are also volatile. For example, naphthalene balls. So naphthalene ball, when you keep it here for a few hours, then what will happen? It get decrease in the size. So some of the solids are volatile. Some of the liquids are also volatile, like ether and like petrol, acetone, alcohol. These are the volatile examples of the volatile liquids and volatile solids. So what we are going to study here is about the non-volatile solute. Here I am having the non-volatile solute, sodium chloride salt, or it is also called as a common salt. So I am having the common salt, and common salt is a non-volatile solute. It does not get vaporized and it does not get converted into the gas state. Okay. Now I am having these two beakers, and both of these beakers are containing water. As mentioned here in this figure, that we are going to take the pure solvent. So here it is pure solvent and the molecules are shown, and I am going to put the gas jar on it. On this I will put the gas jar. So here I will take the gas jar and I will put it on this beaker. Okay. Now what will happen? The vapors which are produced inside the water, the surface of the water, the liquid molecules which are present on the surface of the water are the volatile. They will be converted into the vapors. And suppose that on the surface of this liquid molecule there are 8 water molecules are present. Actually that are containing crores of the water molecules, but suppose we for the sake of convenience we are going to see this figure. So it is the exact arrangement like this in the figure, and on the surface of the molecule, on the surface of the water, there are 1, 2, 3, 4, 5, 6, 7, 8 molecules are there, and all these molecules can go into the vapor state. So when the water molecule go into the vapor state, then the vapor should be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the vapor pressure. So when the water goes into the vapor state, then it will produce the vapor pressure. So inside this space, from here to here on the surface of the water, there will be pressure is generated due to the vapors which are evolved from the surface of the water, and that is called as a vapor pressure. And the vapor pressure produced by the pure solvent, pure water, is always P01. That means it is always constant value. So you have to remember that whenever the pure solvent is producing the vapor pressure, then that is P01 and it is a constant value. Okay, that you have to remember. Then afterward, what I will do, I will take this salt, 1 mole of the salt. This is 1 mole of the salt, and this 1 mole of the common salt I will dissolve in another beaker, and which is containing exactly the same amount of the water. Okay. So I have taken, I will dissolve it and make the solution. Okay, so it is dissolved now, and what I will do, I have to measure the vapor pressure of this solution also. So what I will do, I will keep this gas jar on it. Okay. Okay, I have kept the gas jar on it. Now the vapor pressure produced in this solution. Now this is the solvent, water only, pure water, and this is solvent plus solute, that is the solution. Okay. So now here the solution will also produce the vapor pressure, but the vapor pressure produced by the solution is less. Why it is less? Because see here, the solvent molecules are water. These are the solvent molecules 1, 2, 3, 4. Now on the surface of the sodium chloride solution, the only 4 water molecules are there. Means the number of the water molecules are decreased. The number of the water molecules are decreased. 1, 2, 3, 4. 4 water molecules only. And the sodium chloride molecules are 4. 1, 2, 3, 4. Because of what? Because I am having 1 mole of the solvent and 1 mole of the solute. So equal number of atoms of the solvent molecule and equal number of the atoms of the solute molecule. So here 4 solute molecules are there on the surface and 4 water molecules are present on the surface. So here what will happen? The solute molecule, that means the sodium chloride, it is shown in the dark circle. So 1, 2, 3, 4. They will not get converted into the vapor state. Why? It will not get converted into the vapor state because they are non-volatile. Okay. So the first concept, that is the non-volatile solute. So it will not go into the vapor state. So what will happen? Only the water molecules or the solvent molecules will go into the vapor state. Now how many water molecules will go into the vapor state? So how the molecules which are present on the surface. So how many surface water molecules are there? 1, 2, 3, 4. So these 4 water molecules will go into the vapor state. 1, 2, 3, 4. Okay. So here the vapor pressure here is, this is called the vapor pressure of the solution. Actually this is the vapor pressure of the solvent, but it is produced by the solution, so I will call it as the vapor pressure of the solution. So what is the vapor pressure of the solution? It is P1. Now here this vapor pressure of the solution P1 is less as compared to the vapor pressure of the solvent. So vapor pressure of the solvent, see here 8 molecules are there and that is going to produce more vapor pressure here, and here only 4 water molecules and vapors are there and it will produce the less vapor pressure. Now here after addition of the solute, after addition of the salt in this, the vapor pressure is decreased. Vapor pressure is decreased. So see that decrease is there. Here it is more vapor pressure, here it is less vapor pressure. Now how much amount of the vapor pressure is decreased? So here it is written that vapor pressure of the solution is less. Here the vapor pressure of the solution is less. So therefore the lowering of vapor pressure, lowering मतलब कितना कम हो गया, वेपर प्रेशर कितना कम हो गया, तो ये मुझे फाइंड आउट करना है वेपर प्रेशर कितना कम हो गया. So originally the vapor pressure was P01 of the pure solvent and the solution is having the vapor pressure of P1. तो कितना कम है? P01 minus P1. तो P01 minus P1 कितना है? Delta P1. So it is the difference in the vapor pressure. That is delta P1. Now as you know, this delta P1, that means the lowering of vapor pressure. This is called as the lowering of vapor pressure. So the lowering of vapor pressure, that means the delta P1. Okay, this value is very important. These words are very important. The lowering of vapor pressure. So the lowering of vapor pressure changes as the amount of the solute is going to change. Now if I add the more amount of the solute in this beaker, then what will happen? Then the vapor pressure will be decreased more. Here only there will be 2 molecules will be there in the vapor pressure and it will produce less amount of the vapor pressure. So by addition of more and more amount of the solute in this, then the vapor pressure is going to decrease. So that is called as the lowering of vapor pressure, and that is depending upon what? That is vapor pressure changes as the amount of solute is going to change. Now amount of solute means what? Amount of solute means the mole fraction x2. Mole fraction x2. So whatever amount of solute which is added here, that is represented by x2. So here inside this beaker the solute which is present in it, that is called as a x2. x2, that is the amount of the mole fraction of the solute. So I can write down the equation like this. Therefore, the lowering of vapor pressure is directly proportional to the amount of the solute or the mole fraction of the solute. Okay. Now, whenever I have to remove this proportionality sign, then I have to put the equal to and one constant. Here I have put I have written the constant value as P01. Because of what? Because we know that vapor pressure of the pure solvent is a constant value. Okay, vapor pressure of the pure solvent is always constant value. So therefore equal to P01 into X2. So the lowering of vapor pressure is equal to P01 into X2. Now here what is delta P1? Delta P1 is the lowering of vapor pressure. That means P01 minus P1. So I will write down like this. Delta P1, that means P01 minus P1, that is equal to P01 into X2. Okay. Now I will shift this P01 at this side, at the left hand side, then the equation will become like this. P01 minus P1 divided by P01 is equal to X2. Now here this quantity is called as the ratio of the lowering of vapor pressure. So the ratio of the lowering of vapor pressure is the relative lowering of the vapor pressure. So the relative lowering of the vapor pressure is equal to mole fraction of the solute. So this equation itself is the definition of the Raults law. See here, the Raults law. So what Raults law says? Raults law for the non-volatile solute, it defines that the relative lowering of the vapor pressure is equal to the mole fraction of the solute. So relative lowering of vapor pressure is equal to the mole fraction of the solute. Okay. So what I will do? I will add more amount of the solute in it. Then what will happen? After adding the more amount of the solute in this, what will happen? So I have added this, I have added this also, I have added this also. Then what will happen? See what change will happen in the vapor pressure. So here the number of the molecules I will show with the help of the chalk here what is happening here by addition of the more salt. So by addition of the more salt, what will happen? This molecule is also a salt. This molecule is also a salt. Okay. So what will happen? Only two molecules will go into the vapor state. This molecule and this molecule. And here only two molecules. I will show in the vapor state only two molecules. So vapor pressure is going to decrease. Vapor pressure now it is decreased by addition of the salt. Now how much amount of the vapor pressure is decreased? So it will be given by the P01 minus P1, that is the delta P1, that is the lowering of vapor pressure. So the lowering of vapor pressure is proportional to what? Is proportional to the mole fraction of the solute, which I have added here. So the lowering of vapor pressure is directly proportional to the mole fraction of the solute. So therefore the lowering of vapor pressure, I will remove the proportionality sign and I will add the equal to and the constant of proportionality. The constant here is P01. So P01 and therefore I will substitute here in the delta P1, that is the lowering of vapor pressure is P01 minus P1 is equal to, here it is P01 X2. Now here I will shift this P01 at this side and it will become the relative lowering of vapor pressure. Relative lowering of the vapor pressure. So relative lowering of vapor pressure is equal to what? Mole fraction of the solute, which I have added here. So what is the Raults law? See again, the Raults law says that for the non-volatile solute, what is the Raults law? The relative lowering of the vapor pressure is equal to the mole fraction of the solute. Okay, clear the concept? Okay, thank you.